Beginning week 6, I'm so glad many of you came online today, just because I feel like we haven't had a lot of personal interaction, and I think it's important that we kind of, hang out with your teacher a little while. Factoring special cases. We've had stuff like this where we'd had x squared, let's say plus 5x plus 6. I'm doing a very simple one. And we made the little squares. We filled in the boxes, x squared and 6, and then we would multiply across and you would get 6x squared. You'd multiply these two items together, and then the 5x here, and you play the game, what numbers multiply to make 6 that add to make 5. And that's pretty easy, 3 and 2, so we would go 3x and 2x. And we're still going to do that, but we have a couple special cases. My phone is ringing and it goes straight to the classroom, so let me we'll just let it leave a message. I'll ignore them. You guys are more important. So when I have something like this, the reason this is a special case is because x squared minus 49 are both of these are what's called a perfect square. This is a perfect square because of x times x. This is a perfect square because of 7 times 7. And that middle term is like a 0. So if I were to make my little box right here, right, I would put the first term here and the bottom term here, and multiply across, and you get negative 49x squared. Now my middle term would go on the bottom. So it's what numbers multiply to make 49 that add to make 0. So the first thing that pops into my mind for 49 is 7 and 7, and look at it, positive 7 and negative 7 will add to make 0, right, 7x and 7x, and it will multiply. So you'd get 7x and negative 7x. Now watch what's going to happen. When we factor this, here you're going to get an x and an x. X times x. Well, x times what makes 7x? A negative 7. And x times what makes positive 7? 7. So look at what we get. We get x plus 7, x minus 7. So anytime that there's a difference, which means it's a subtraction sign, a difference of two perfect squares, it's just going to be x plus, like, whatever makes that number. So if let's do a practice one. What if I did x squared minus 25? This is a perfect square, x times x. This is a perfect square, 5 times 5. This is the difference of two perfect squares. So I would just write x plus 5, x minus 5. And you don't have to memorize this, because you can always go through the same box process every single problem. Let's try another one. What if I did x squared minus 81? What numbers multiply to make 81? X plus 9, x minus 9. Okay, so that would be the answer for that one. What if I had x squared plus 36? No, oh yeah, 6. But notice, this is a plus. It's not going to work because it has to be the difference. It has to be minus. So this would be not factorable. I'm going to squeeze it in there, because it must be a difference, or a subtraction sign. Must be a difference. Okay, so let's go over here. This, we know that 25 is a perfect square because we already did it, 5 times 5. But what multiplies together to make 4x? What multiplies together to make 4x? What times what makes 4x? How about 2x times 2x? Right? So this is a perfect square because 2x times 2x. This is a perfect square because of 5 times 5. So we can say 2x plus 5, 2x minus 5. It doesn't matter, I can put the minus first, but it's a difference of two squares. That is what's the important thing. So what summarizes, I'll come back and do the right side, but take notes and summarize the special cases of factoring. Well, the difference of perfect squares, it has to be perfect square factors separated, I think I spelled that wrong, by a subtraction sign, or difference sign.
Wait, Miss St. John?
Yes?
When you said the 2x times 2x, you said 4x. Isn't that 4x squared?
Right, and see, this is 4x squared.
Okay.
So 2x times 2x is 4x squared. Okay, perfect, good observation. But when you do difference of perfect squares, it actually has to be perfect square factors. So let's look at this example at the bottom. Is 25x squared a perfect square? 5x times 5x. Is 1 a perfect square? What makes 1? 1 times 1. So how can I write that super fast and easy? I can factor that by 5x plus 1, 5x minus 1. That's how quickly you can solve this problem, because it's a difference of two perfect squares. Okay, so that's one part of the special factoring cases. The second part is called a perfect square trinomial. Okay, so perfect square trinomial. And how this works is, okay, we see that this is a perfect square, x and x. We see that this is a perfect square, 5 and 5. But notice these numbers, 5 plus 5, add together to make 10. They add together to make 10. So what's the little rule on this one? Well, let's do it the long way, because you can always do this method using the squares. You don't have to, basically with this lesson, you don't have to learn any of these shortcuts. You can just always go to this box and work it out. So here you get x squared and you get 25. And we're like, okay, what multiplies together to make 25x squared that makes a negative 10x? Well, I'm going to have negative 5x and negative 5x. A negative and a negative make a positive 25, and negative 5x plus negative 5x makes 10x. And so I'm going to put negative 5x here, negative 5x here. I'll go to a different color because I'm getting a lot of stuff on this page. So again, we can have an x here and an x here. Now I'm just doing it on the bottom just because I'm running out of space here. Well, what multiplies to make this one? Negative 5. What multiplies, because negative 5 times x makes negative 5x. X times what makes another negative 5? How about another negative 5? Oh, look it, I have negative 5 and negative 5. So my answer is x minus 5 squared. Or I could have wrote x minus 5 times x minus 5. Right? But I can write that as squared. So it's a perfect square trinomial. I know I did that pretty fast. What's important about this one is that whatever this number is has to add to make this other one. If I, like, this is going to be 5x and 5x. Let's apply it to this next problem. Let's apply it to our next problem. So this, again, we know that this is 5 and 5. 25 is a perfect square, 5 times 5. 4x is a perfect square because of 2x and 2x. Well, what if I multiplied a 2 times a 5? 2 times 5 is 10. And then this 2 times 5 is also 10x. And 10x plus 10x would be 20x. So my guess would be that I would take this first term, 2x, and I'd put a 5 here and I'd put a square. Well, is it plus or minus? Notice this problem, it was a minus 10, so they ended up being negative 5. Here it's a positive 20, so it's going to be a positive. Okay, and just to prove it, let's go through this little method right here, where you have 4x squared here and 25 here. This is going to be 2x and 2x. We have to multiply. What numbers multiply to make 100x squared that add? Am I going too fast? And multiply these two to get the top number, and then you need 20x on the bottom. What numbers multiply to make 100 that add to make 20? Oh, 10x and 10x. So I'm going to put 10x and 10x. Well, what can we factor out? We know this is 2x and 2x. 2x times what makes 10? That's going to be a 5. 2x times what makes 10? Oh, it's going to be a 5. So do you see I have 2x plus 5 and 2x plus 5? Which I can write 2x plus 5. 2x plus 5. Oh, but simply put, it's 2x plus 5 squared. Now this is a shortcut, but you don't have to use the shortcut. You can always just work it out the same way, using the box method. Perfect trinomial square. Again, you have to have perfect square factors for the first and last terms. And then when you multiply them, they should add to the middle term. Let me explain what I mean. Perfect square factors for the first and last terms. This is 9x squared. This is 3x times 3x. And this is 2 times 2. So 2 times 2. Well, and when I multiply them, a 3x times a 2 is a 6. Well, and a 3x times a 2 is a 6. So 6 plus 6 make 12. So I know it's going to be 3x and a 2 squared. But do I put a plus or a minus in here? Okay. The plus or the minus term comes from here. You're going to look at that first term, and because it's a minus, we're going to put a minus. And that's basically the shortcut for factoring, but these are only in special cases. It only works when you have a difference of squares or a perfect trinomial square. It works for these two things. Okay? Now, in this packet, there is a page missing. It only has 6 questions on it, so I'm going to put those 6 questions up in Schoology for you guys to do for homework on this and practicing those 2 techniques. All right.